to the same base as the logarithm. So I'm going to rewrite this as the log of 5, and I'm going to rewrite 25 with the base of 5 instead. So I can rewrite 25 as 5 to the exponent 2. And so I know the answer in this case will be an answer of 2, since if I'm trying to consider 5 to some exponent is equal to 5 to the exponent 2, I know that the exponent has to be the same in both cases. So the exponent has to be an exponent of 2. Okay, I can do the same thing for the next one. Again, I know that I can write 27 with the base of 3. And the base of my logarithm is 3 as well. So I'm going to rewrite 27 as 3 to the exponent 3. And so the answer in this case would be 3. 3 to some exponent gives me 3 to the exponent 3. And that means that the exponents have to be the same for it to equal 27. The next one's a little bit different. You have a base that's a fraction. And so I'm still going to try to write this statement with a base of 2. So let's start by writing log base 2. And ideally I want to try to write this as 2 to some exponent. Now because I know that the numerator has a multiple of 2 in it, I know this will have a negative exponent. And so the first thing I'll do is write the denominator with a positive exponent. So 16 can be rewritten as 2 to the exponent 4. Okay, and it's starting to look the way I want it to look. The only problem is that the number that I'm looking at with the base of 2 is in the denominator. So to get it back into the numerator, I will write the reciprocal of the base, but with an exponent that has the opposite sign. So in this case, since the exponent in the denominator is positive, in the numerator would have a negative exponent. So it would be 2 to the exponent negative 4. Okay? Just to look at this again, just to make sure I'm correct. 2 to the exponent negative 4 is the same as 1 over 2 to the exponent positive 4. And that's the same as 1 over 16. So we're on the right track. And so now that the base of the answer is the same as the base of the logarithm, I know that the exponent that's on the in the answer part is what the logarithm would be equal to. So negative 4 in this case. Okay, in part D, this one, notice that there's no base that's indicated. I know this one is a common logarithm. The base here is a base of 10. And so there's a couple of different ways of doing this. You can try to write the answer with a base of 10, or you can use your calculator. And so if I look at the log of 0.001, I get an answer of negative 3. Now, what that means is 10 to the exponent negative 3 gives you a result of 0.001. And that's correct. Okay? So if you wanted to try to do this without using your calculator, because the base was not indicated, you would write this as log of 0.001. You would try to write the answer part with a base of 10. So 10 to some exponent will give you 0.001. And I know that that exponent is negative 3. And so since the base of the answer and the base of the logarithm are the same, then the exponent on the answer is what the logarithm is equal to. All right, last example.